Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are starting with differentiation, the differentiation of P3, that is paper 3. So this is 9709 and paper 3, and there are different variants that could be 31, 32, 33, and now they even have the fourth variant which is 35. So let's get started with the basic. First of all, if I review what we have done in differentiation in P1. So now basically we have done two things. The first thing is y is equals to a constant a multiplying with a variable x raised to power of n. When we find dy by dx, the first derivative, the differentiative, a remains as it is, power comes down, x remains as it is, power reduces by 1. So that is basically what is happening. X raised to power of n becomes n, x raised to power of n minus 1. This constant a remains as it is. That is the basic differentiation. So remember, dy by dx is known as the gradient function. And why do we call it the gradient function? Because it gives the gradient of tangent to the curve at a particular point. And I think this image says it all. So let me just highlight on this image. And this is the curve, and this line that you're seeing over here, that is the gradient of the tangent. So now that is how you draw the tangent. And if I draw a perpendicular to this one, that would be the normal. So let me just mark over here, n stands for normal. And over here, this t stands for tangent. And naturally they are perpendicular to one another. So now coming back to this, that is rule number 1, and there is also rule number 2, that is about the chain rule of differentiation. What is this rule? Y is equals to something inside the bracket raised to power of n, dy by dx, power comes down, bracket remains as it is, power reduces by 1, and there is something that you should not forget. What is that? Don't forget to multiply by derivative of bracket. So differentiation is the new term, derivation is the old term. So what we get from after differentiation, that is known as derivative. So don't forget to multiply by derivative of bracket. So this is rule number 1. And this one is rule number 2. So now in this particular video, what I'll be focusing on, that is the product rule. So let me draw a box over here. And this box has this rule written in it. The rule says y is equals to u into v. U is a function of x, v is a function of x. Therefore, dy by dx, u gets multiplied with v prime, the first derivative, and v gets multiplied with u prime. So u prime, that is the first derivative of u. So derivative of u. Similarly, v prime, that is the first derivative of v. So basically what is happening? So we have u multiplying with v prime, we have v multiplying with u prime, and there is a positive sign in the middle. So let me do 3 basic examples on the product rule. So now let me write the first example. Y is equals to 2x plus 3 multiplying with x square plus 1. So now this one in red color, let me write this thing as u. So u is 2x plus 3. And let me write underneath u prime, which is simply 2. And this thing in purple color, that is x square plus 1. So v is x square plus 1 and v prime is simply 2x. So basically it's kind of like cross multiplication. If you want to label it this way, u gets multiplied with v prime, v gets multiplied with u prime. So let me write it out. So therefore dy by dx equals to 2x into 2x plus 3. And this is 2 into x square plus 1. Simplify it a bit more. That is 4x square plus 6x plus 2x square plus 2, and 4 plus 2, that is 6x square, and then it's a 6x and then a 2. That is the value, the expression, not the value, the expression for dy by dx. This is worked example 1. Let me go ahead and make another worked example for you people. Y is equals to 3 minus 2x, and this is 1 plus 5x raised to power of 3. So again, let this be u. So u is 3 minus 2x, and u prime is simply negative 2. And over here we have v, that is 1 plus 5x, the whole thing raised to power of 3. Now it will be differentiated according to chain rule. That is 3. This is 1 plus 5x, power becomes 2, derivative of bracket is 5. And of course we can multiply this 3 and 5, that will make it 15. Again, follow the same process. Multiply like this, and there is a positive sign in the middle. So dy by dx, that is equals to 3 minus 2x, use brackets excessively. This is 15. This is 1 plus 5x, the whole thing square. And then over here, this is negative 2. This is 1 plus 5x, the whole thing cube. So now my personal preference is that skip the constants, even if you don't want to take initially the common at the moment. Skip it for right now. In this case, you cannot. Focus on what? Focus on this thing. That is over here. That is 1 plus 5x whole squared, 1 plus 5x whole cube. So what can you take common out? So you can take 1 plus 5x, the whole thing square, common out. And then what's on the inside? So this is 15, 3 minus 2x. And this is negative 2 into 1 plus 5x. I hope this step is all good, all clear. Now let's just simplify. On the outside, there is nothing to simplify. Do not open up the bracket, leave it intact. It looks beautiful. This is 45 minus 30x. This is negative 2, negative 10x. Do check my working. So this is 1 plus 5x, the whole thing square. And this is negative 30, negative 10, that is negative 40x. And 45 minus 2, that is 43. So that is the expression for dy by dx. So now there was an application of chain rule, and that leads to taking common. So taking common should always be one of the prime responsibility in finding, in using algebra and things like that. So this is worked example 2. Let me look at work example 3. So let me write y is equals to x cube plus 1 into square root 1 plus 2x. So again, let me write over here, this is u, that is x cube plus 1. U prime, that is 3x square. This one is v, that is 1 plus 2x raised to power of half. Of course, in order to differentiate it, I need to use indices. And v prime, that is half 1 plus 2x negative half, derivative of bracket is 2. And let me simplify it over here. This is 1 over square root 1 plus 2x. So basically, this 2 and this 2 cancels out. This negative half, it makes it go down. So now apply that knowledge. That goes like this, that goes like this. And therefore, this is dy by dx. And let me just move my name a bit over here. That is x cube plus 1 over square root 1 plus 2x. Positive sign over here. 3x square multiplies with square root of 1 plus 2x. So after the differentiation is done, I'm back to the third form. So 1 plus 2x raised to power of half is this thing. This one is this thing. Positive sign in the middle. Now you need to simplify it. You need to take LCM. So when we take LCM, so we will write this thing. That is a straight line like this. This is square root 1 plus 2x. x cube plus 1 remains as it is, and this 3x square, and what happens over here? Something to do with surds happen over here. Root a equals to a. Root 1 plus 2x, root 1 plus 2x is basically 1 plus 2x. So now this is 1 plus 2x. And let's open this up. So this is x cube plus 1, and this is 3x square, and this is 6x cube. Divided by square root 1 plus 2x. And therefore this is x cube, and this thing 7x cube, 3x square plus 1 over square root 1 plus 2x. So have a good look at this. The thing special in this one was the involvement of surds. So now 3 examples are good enough. This is the exercise on product rule. So now these are the basic questions. 2 brackets are multiplying together, application of chain rule, things like that. Questions involving the surds over here. In this one, there are 3 brackets. So what is the knowledge that you should use over here? First multiply these 2, then apply product rule. First multiply these 2, then apply product rule. What is special over here? Nothing. 4 is nothing. 5. A curve is defined by such and such. Find dy by dx and the gradient at the point 5, 10. So just plug in the value of 5 and you find the gradient. At the points where it crosses the x-axis, therefore, what should you write? Y is equals to 0. You will find the values of x. So therefore, x is -1, x is +1, and then find dy by dx, and then do the plugging in. So I think these are pretty basic questions. Okay, let's move on. The answers are over here. And now let's focus on quotient rule. So quotient rule, we have to be careful of few things. So let me first draw a box over here. And then I'll write y is equals to u over v. So u is the numerator. And then v is the denominator. So now the order makes a difference. Of course, you have to be specific. U is numerator, v is denominator. Dy by dx, that is, first of all, we have a fraction and the denominator is basically v square. And we start with v, u prime minus u v prime. Of course, it's written in the formula booklet MF19, but once you do a lot of practice, you will remember it. So now the first worked examples. Example, y is equals to 2x plus 5 over x square plus 1. So now there is red and green. So let me use this thing in red. So u is 2x plus 5. And over here, we have the other thing, u prime. First differentiate, that is 2. And then v is x square plus 1 and v prime is 2x. Now let's get started with v and draw an arrow like this. So I'm also telling you which techniques, how to be more better at maths, how to apply these techniques, dy by dx. So now dy by dx equals to, first of all, draw a line. And that is for the denominator, that is x square plus 1 whole square. No need to open this up. So this is x square plus 1 into 2 minus 2x into 2x plus 5. Let me write it for you. This is v, this is u prime, this is v, this is u prime, minus this is u, and this is v prime. This is u and this is v prime, divided by v square. Exactly following this process. So now let's do a bit of simplification. That is 2x square plus 2 minus 2x into 2x. That is 4x square, 2x into 5. That is 10x. The whole thing divided by x square plus 1 whole square. So 2x square minus this thing. That is negative 2x square. And this is plus negative 10x plus 2. So I can write it like this, divided by x square plus 1 whole square. That is the expression for dy by dx according to the quotient rule of differentiation. The second worked example, let me make a question. Y is equals to 1 plus 2x cube, and this is x plus 1. Let's make it simple. So u is the numerator, x plus 1. U prime, simply 1. And over here, v is 1 plus 2x, the whole thing cube. V prime, that is 3, 1 plus 2x, power reduces by 1. Don't forget the derivative of bracket, which is 2. And then start from here, like this. So therefore, dy by dx, don't forget the denominator line. First of all, this is 1 plus 2x whole cube raised to power of 2. So remember this rule, a power m raised to power of n, the powers multiply, a m n. So this 3 will multiply with this 2, that will become 6. I'll write it in the second line. So let me just again draw a line over here, and let me just focus on this. This is 1 plus 2x raised to power of 6. So now over here, when I simplify this thing, this is 1 into 1 plus 2x whole cube minus 6, 1 plus 2x whole square into x plus 1. Always a good idea to double check. So this is the cube thing into 1, cube thing into 1. Negative sign, 3 into 2 is 6, into this thing square, all good, into x plus 1. Perfect. So now I should take something common. And what is that something common? That is 1 plus 2x cube. This is 1 plus 2x whole square. So this is basically 1 plus 2x whole square. Got the idea? And then what's happening on the inside? It's simply 1 minus 6 and x plus 1. So now 1 minus 6 is negative 5, negative 6x. Okay. And what else is there? This thing will simplify. 1 plus 2x whole square, 1 plus 2x whole power 6. This is 1 plus 2x power 4. I think that is very obvious. And of course, if you want to, you can take the negative 1 common out. So negative 1, 5 plus 6x divided by 1 plus 2x raised to power of 4. So I think that is a nice example. Chain rule, whenever chain rule comes, there is always something to take common, and cancellation is also happening in this case. The third example, that is something involving the square root. So therefore, 3 plus 4x square root divided by 1 plus 2x. So again, u is 3 plus 4x raised to power of half, and u prime is half 3 plus 4x, negative half, derivative of bracket is 4. Simplify it over here. So this is 2 over square root 3 plus 4x. And over here, v is 1 plus 2x. v prime is simply 2. And we will be starting with v. So therefore, dy by dx is equal to, let me draw a line over here, but now this time I'm changing my mind. I'll just let you know why I did change my mind. So therefore, this is v into this 2 times 1 plus 2x, 2 times, no, not this thing, change this thing. This is 2 times 1 plus 2x, that's in the numerator, over square root 3 plus 4x. And then there is a negative sign. This is 2 into square root 3 plus 4x. Now let me use the traditional division sign. I don't want things piling one on top of the other. There is v square, which is 1 plus 2x whole square. So now this is just like the third work example of quotient rule. Let me just show it to you. This is like this one, the third worked example of product rule. My bad, that's product rule. The one that we are doing is the quotient rule. So what do? We take the LCM, but there was no denominator over here. So therefore, when I'm doing this thing, there is this denominator. That is why I have written using the traditional sign on the sidelines. So now let me simplify this thing. This is square root 3 plus 4x, and this is 2 plus 4x, that is this thing, minus 2 times 3 plus 4x. The same knowledge over here, the square root multiplies, and we are getting this thing. Got it? And now let me put this sign over here. Let me put a division. This is 1 plus 2x whole square. So therefore this is 2 plus 4x minus 6 minus 8x divided by square root 3 plus 4x, big bracket, division 1 plus 2x whole square. So therefore 2 minus 6 is negative 4, minus 4x divided by 3 plus 4x square root bracket 1 plus 2x whole square. And therefore let me take negative 4 common out, 1 plus x divided by square root 3 plus 4x into 1 plus 2x whole square. That is the expression for dy by dx. So now this is the example for the quotient rule, basic questions, question involving square root, something written in terms of fx, and we need f prime x. Somewhere you have to find dy by dx at the point where x is equals to 1 and things like that. And that is the answer over here. So now we are done and dusted. So this is P3. This is differentiation. We reviewed the basic of P1, and then we did 3 examples of each, the product rule and the quotient rule. So 3 examples of this, 3 examples of this, and we are all set for things to come. Stay tuned for more content on Mathematics with Shahab Yaqub.